Welcome you students. Now we are going to learn about Laurent series. The statement says that if f of z is analytic on two concentric circles, say C1 and C2 of radii R1 and R2 with center at A and also on the annular region R bounded by C1 and C2, then for all z in R, f of z equal to sum of n equal to 0 to infinity an into z minus a to the power n plus sum of n equal to 1 to infinity bn by z minus a power n, where the constants an can be found out by the help of integration f of z by z minus a to the power n plus 1 into dz multiplied by 1 by 2 pi I and bn equal to 1 by 2 pi I integral over c to f of z by z minus a to the power 1 minus n into dz. So here we are having two circles. But it is a concentric circle. Okay, let us consider the concentric circle with center A. Here you are having, let us take the center as A and radius of this circle, let it be R1. The circle C1 is evaluated in anti-clockwise direction and circle C2 we are having, that is also going to be counted in anti-clockwise direction, which is having radius R2. The function f of z is defined in this annular part. Okay. So here the Laurent series expansion is having the positive powers of z minus a and negative powers of z minus a. If they are asking in the question, find the Laurent series expansion, that Laurent series expansion including the Taylor series also. If you are seeing the Taylor series expansion, you can find out only the positive powers of z minus a. So Laurent series including positive powers as well as negative powers. If you are getting only negative powers of z minus a in the problem answer, then also it comes under Laurent series expansion only, where there is no positive powers of z minus a. Okay, so it is truly Laurent series there. If you are having only positive powers of z minus a, the Laurent series can be called as Taylor series. That is, Taylor series is a special case of Laurent series. Here, this part, first part is called the regular part. This is called regular part. And the second term is called the principal part. So in your exam, they may ask it in one word question. The regular part of Laurent series is the first part, that is positive powers of z minus a, and negative powers of z minus a is called principal part. Now come to this problem. Find the Laurent series for the function f of z equal to z minus 1 by z plus 2 into z plus 3 in the region modulus of z lies between 2 and 3. Here, to find out the Laurent series expansion, we have to have single z minus a term in the denominator. But if you are seeing the function, we are having multiplication of z plus 2 and z plus 3. So we can divide it with the help of partial fraction method. Z minus 1 by z plus 2 into z plus 3. First, divide it by making use of partial fraction method. It can be written as a by z plus 2 plus b by z plus 3 since the power of z is 1. Now by taking LCM and cancelling the denominator, you will get z minus 1 equal to a into z plus 3 plus b into z plus 2. By putting z equal to minus 3, okay, if you are putting z equal to minus 3, you will get this term, or I can say by putting z equal to minus 2 for getting the value of a. Put z equal to minus 2. So what you will get? Minus 2 plus 3 gives you 1. A. Here this term will be a and this term will become 0. So here it is going to be, put z equal to minus 2, a equal to minus 3 you will get. Then by putting z equal to 3, z equal to minus 3, here what you will get? Minus 3 minus 1 equal to a into 0 plus b into minus 1. Therefore, b equal to 4 you are getting. So, like this, finding the value of a and b and substituting here, you will get minus 3 by z plus 2 and 4 by z plus 3. Now we have to find out the expansion in the region mod z lies between 2 and 3. That is, you are going to have the annular region. Okay. So, you are having two circles. Okay. It is a concentric circle only. One is having the radius as 2 and the other is having the radius as 3. This is mod z equal to, let us take C1 and this is C2. Here C1 is mod z greater than 2 and C2 is mod z less than 3. That means what? Mod z greater than 2 means you can write this as x square plus y square is greater than 2 square. That means you have to consider the circle outside of the region of this circle. Okay, center 0, 0 and radius to exterior of this circle. Then this mod z less than 3 means you have to consider interior of the circle x square plus y square is less than 3 square. So this portion, this annular part, we are going to have as a region of this integration. Here only the function f of z is defined. Okay. Now, mod z greater than 2. We understood that the power series expansion valid only in the region mod z less than 1 category. So, to make it in that form, mod z less than 1 form, you are going to take the inversion of this, that will give you 1 by modulus of z is less than 1 by 2. By bringing this 2 to this numerator, you will get 2 by mod z is less than 1. Okay, here you are having the region, annular region mod z is less than 3. To bring this as mod z less than 1 form, you have to bring this 3 to the denominator. So mod z is less than 3 is less than 1. Now 2 by mod z is less than 1 and modulus of z is less than, modulus of z by 3 is less than 1. So you have to identify this region can be applied in what term and this region can be applied to what term. So this region here you are having 2 Okay, so from this term, you are having 2. Therefore, by keeping 2 this side and taking z outside, you can able to get this form. 1 plus 2 by z by taking z outside. And here you are having z plus 3. Therefore, for this z plus 3, we are going to apply the region modulus of z by 3 is less than 1. So, to apply in this region, we have to take 3 outside. By taking 3 outside, you will get, okay, z divided by 3. Z divided by 3. Then, minus 3 by z into 1 plus 2 by z whole power minus 1, you can write it in the numerator. Likewise, plus 4 by 3 into 1 plus z by 3 whole power minus 1. Expanded by making use of power series. You should not stop in this step. You have to expand this by making use of power series. So what is that power series expansion? You are going to get minus 3 by z into 1. Alternative terms are positive and negative because here you are having positive and this step is power is negative. So minus 2 by z plus 2 by z the whole square minus 2 by z the whole cube, etc. Second term is going to be 4 by 3 into 1 plus, here also you are getting positive and negative because you are having positive here minus power here. So minus z by 3 plus z by 3 the whole square minus z by 3 the whole power 3, etc. Now by writing the generalized form, we are going to get this equal to minus 3 by z into sum of, since alternative terms are positive and negative, you have to put minus 1 to the power n into 2 by z the whole power n. Here if you are putting n equal to 0, you will get the first term. By putting n equal to 1, you will get the second term and so on up to infinity. The second term also you can write it in this manner. Here sum of, okay, minus 1 to the power n into z by 3 whole power n, where n is ranges from 0 to infinity. So you can look this series expansion f of z. Here you are having negative powers of z, okay, as well as positive powers of z. That's why it is called Laurent series expansion. Okay, in the annular region, you will get negative powers of z, okay, as well as positive powers of z. Hope you understood. So, here the things to be noted are the degree of numerator should be less than the degree of the denominator. If not, you have to make it in that form. The degree of the numerator should be less than the degree of the denominator. Then you have to expand it in the given region. Now we'll move on to the next problem. Find the Laurent series for f of z equal to 1 by z square minus 3z plus 2 in the region. First cases, mod z lies between the annular region 1 and 2. Second case, mod z is greater than 2. Third case, mod z minus 1 is less than 1. So first, we are going to split the denominator of the function. That I can able to get it as f of z equal to 1 by 1 minus z square minus 3z plus 2 can be written as z minus 1 into z minus 2. So we are going to separate it. by making use of partial fraction method, and we are getting the answer of A and B as minus 1 and 1. Substitute it here. You will get, in the first region, it is annular region. This region 1 less than mod z less than 2 can be written as mod z is greater than 1 and mod z is less than 2. Already we understood that the power series is valid for the function 1 plus z is valid when mod z is less than 1. So to bring in that form, you have to invert it. 1 by mod z is less than 1. Here already it is lesser form only, lesser inequality only. But here you are having 2. So to make it as 1, dividing both terms by 2, you will get mod z by 2 is less than 1. Therefore, this 1 by mod z less than 1 can be applied for the first term, and mod z by 2 less than 1 can be applied for the second term. So from the first term, you have to have 1 by z format. Therefore, take z outside from the first term. That will give you 1 minus 1 by z. Then second region, mod z by 2 is less than 1. So take 2 outside to make it in that form. That gives you 2 into z by 2 minus 1. Now, bringing this denominator to the numerator, it should be like 1 minus x or plus x whole power minus 1. So this is going to be 1 minus x plus x square minus x cube, etc. if it is positive. If you are having 1 minus x power minus 1, all terms are going to be positive. So, to make it in this form 1 minus x format, I am taking minus sign outside. That gives you minus 1 by 2 in the second term into 1 minus z by 2 the whole power minus 1. Now apply the formula. This comes under second category, like all the terms will be positive. So expand it by making use of power series expansion, and you have to write down the simplified form, or you can write down the generalized case. So this is going to be minus 1 by z into 1 plus 1 by z plus 1 by z the whole square, etc. minus 1 by 2 into 1 plus z by 2 plus z by 2 the whole square, etc. By writing the generalized form, you are going to have minus 1 by z sum of 1 by z whole power n, where n is ranges from 0 to infinity, and then plus it is minus only, minus 1 by 2 times sum of n equal to 0 to infinity z by 2 whole power n. Now in the second region, what is the second region? We are having mod z is greater than 2. So both terms, okay, minus 1 by z minus 1 and plus 1 by z minus 2, you have to expand it in the region mod z greater than 2. Therefore, to make it as mod z less than 1 form, we have to invert it. By doing the inversion, we are going to get 1 by modulus of z is less than 1 by 2. By bringing this 2 to the numerator, okay, you will get 2 by mod z is less than 1. So, here you are having 2 by modulus of z is less than 1. If you are seeing the first term, you are having z minus 1. Okay. In that case, what you will get? 2 by z is less than 1. So what about the case, okay, 1 by mod z? So 2 parts of 1 by z is less than 1. This implies 1 by mod z is also less than 1. Therefore, from the first term, you have to take z outside. So you will get 1 minus 1 by z. From the second term, take z outside. You will get 1 minus 2 by z. Now expand it by bringing it to the numerator. So by doing the expansion, you are going to get minus 1 by z into, okay, 1 plus both terms are negative itself. So 1 by z plus 1 by z square, etc. Then from the second term, 1 by z into 1 plus 2 by z plus 2 by z the whole square, etc. By writing the generalized form, we are going to get minus 1 by z into sum of 1 by z the whole power n, where n is ranges from 0 to infinity, then plus 1 by z into sum of, okay, 2 by z is power n, where n is ranges from 0 to infinity. So you can see the series, you are having only negative powers of z. This also comes under Laurent series expansion. Here, no positive powers. Okay. Now come to the second. So the second region got over. We have expanded it. Now come to the third region. The region is modulus of z minus 1 is less than 1. In previous cases, okay, here and all, we are getting, okay, the same thing. You can write it as modulus of z minus 0 is less than 2, greater than 1. That is, here the center is going to be 0. Center is 0. Whereas here you are going to have different center. Okay. What is the circle represent here? If you are drawing the circle, here z minus 1. So it will be like x plus iy minus 1 modulus. This gives you what? This gives you x minus 1 plus iy modulus. This is less than 1. This is less than 1. Likewise, it represents the circle x minus 1 the whole square plus y square is less than 1 square if you are taking the modulus. So it represents the circle with center 1, 0 and radius is 1. 1, 0. Okay, this is mod z minus 1 is less than 1. So the circle center is moved to 1 unit. In this case, to solve the problem or to get the series in a simple manner, you are going to do some substitution. What is that substitution? Put z minus 1, that is z minus a, equal to u. So what happens to z? Z will become u plus 1. Okay. We know that modulus of z minus 1 is less than 1. That gives you what? Modulus of u is less than 1. So if we are going to convert this problem into u, put z equal to u plus 1 here, you will get minus 1 divided by u plus 1 minus 1 plus 1 by u plus 1 minus 2. That gives you minus 1 by u plus 1 by u minus 1. So here you are not having any point, therefore you can keep it just like that. If you are having any point here, you have to make use of binomial expansion. So this I can take minus sign outside in and write it in the numerator. You will get 1 minus u the whole power minus 1. Why we are not doing any changes here? Because already we know that, okay, if I am writing this, we know that modulus of u is less than 1. Okay, modulus of u is less than 1. No constant in the denominator or in the numerator, just modulus of u is less than 1. That's why we are not taking any constant outside here. So 1 minus u the whole power minus 1 expanded by making use of power series, okay, and write down the generalized form. So here f of z equal to minus 1 by, okay, put u equal to z minus 1. Here itself, if you are writing the generalized form, you will get minus 1 by u minus, okay, sum of, here if you are expanding it, what you will get 1 plus u square, etc. So it will be sum of, okay, u power n, where n is ranges from 0 to infinity. Put u equal to z minus 1 now. What you will get? Minus 1 by z minus 1 minus, okay, here you will get minus sum of n equal to 0 to infinity z minus 1 whole power n. So this is the final result. Up to the generalized form, you have to write down the result. Hope you all understood this problem. Here you are having three different regions. First is annular part, second is exterior of the circle, and third is interior of the circle with center 1, 0, radius 1. Now you can solve this problem. Expand f of z equal to z square by z plus 2 into z minus 3 in a Laurent series expansion if mod z is less than 2 and mod z is lies between 2 and 3. We'll see it in the next session. Thank you.